A person 2 meters tall walks directly away from a street light that is 8 meters above the ground. If the person is walking at a constant rate and the person's shadow is lengthening at the rate of 4/9 meters per second, at what rate in meters per second is the person walking?
Excellent. Again, you might need to read that to yourself a couple times, but we're going to draw a picture. What are we going to draw a picture of? Yeah, a street light. And we don't need to be artists in this class, so my street light is going to be a big line with the light bulb at top. Okay? Right, there you go. What else? The person. Okay? And you don't have to worry about scale. I'm going to draw my guy way over there. How does that help me? So is the person walking towards or away from the street light? Away from the street light. So the light is coming from behind the person. So on the floor, it's projecting the person's shadow. And you can see that if you connect the tip of the light, go through the guy's head and all the way to the floor, you will be able to sort of see where the shadow would essentially be, which would be kind of in this area over here. Okay. We need to do some more labeling. There are certain measures of this story that are constant. What are fixed about this story?
Street light.
What about the street light?
8 meters tall.
It's 8 meters tall. And also the guy. Right, so clearly I didn't draw this to scale, but we're okay with that. And then there are things that are not fixed, things that are changing. What is changing in this story? The length of the shadow is changing. What else is changing?
Distance from the light pole.
The distance that the man is from the street lamp, because he's walking in this direction. So we need a variable for this distance, and we need a variable for that distance. Let's just use x and y, okay? And just to be clear, x is the distance from the man to the street light, and y is essentially the length of the shadow. This is not the scale, okay? It's probably not quite correct. Oh, all right. Let's twiggy. What are we trying to find?
The rate in meters per second.
So which variable is the guy walking? Which variable is that? Which variable is going to be the rate at which the guy is walking? X or Y?
X.
Y is what?
The shadow.
Y was the shadow. X is the distance essentially from the street light. So no, we're looking for the x dt here. And that would be measured in meters per second. What else do we have? The person is walking at a constant rate, and the person's shadow is lengthening at a rate of 4/9 meters per second. What are we going to call that? That's dy dt. Is that positive or negative? Because they use the word lengthening. Okay? Is there a when moment for this story? There's not. And there doesn't have to be necessarily, especially in a linear situation like this. Sometimes you have two when moments. So we don't have one, and don't freak out about that. Don't freak out about it unless you need something and then you don't have anything. That's when you worry. The hardest part about this problem is coming up with your equation. You need to come up with a way of relating x and y given our picture. Pythagorean theorem always comes up first when I pose this problem. To use the Pythagorean theorem, what additional side would we need? We would need the hypotenuse, which we don't know. Do we want to introduce a third variable? Do we have a third rate? So we want to avoid using the hypotenuse because we don't know anything about it. Area, that always comes up next. Okay? If I involved area, I would have to have a dA dt in my story? Do I know anything about the ADT? We're going to use similar triangles. Okay. I heard someone mention SOHCAHTOA, and that would be another great way of relating things. But again, do we know anything about theta? Okay. All we can use is what we have. We're going to use similar triangles. For those that may not see it, if you look at the outer triangle, we have drawn a right triangle, and our smaller triangle is a right triangle. Okay. And since that angle is the same and they both share this angle, do we all agree that these are similar triangles? So height is to base as height is to base. Okay. So it doesn't matter how you start it. So if I say the height of the big triangle is to its base, what is the base of the large triangle? X plus y. And I'm going to set that equal to 2 over y. What do I do now? No. What? Okay. Could I take a derivative? Yes. Do you want to take a derivative now? No. Okay. So it would be better if we did what? Cross multiply. Yes. You certainly can. But who wants to do all that? So we get 8y equals what? 2x plus 2y. Well, look at how simple this is going to be. Move my y over. I get 6y equals 2x, and why not even clean that up more? What will I have? It doesn't matter. I'm going to leave it without avoiding the fraction. I'm going to leave the 3 on the left hand side there because it doesn't essentially matter when you're doing implicit differentiation. Look at that. Someone suggested taking the derivative. Well, what would you rather take the derivative of? This? Right? Or that? So you can see that sometimes cleaning things up are going to save you some time. Okay. All right, we have our equation. That's our starting off point. This is where you start. Okay. And we're going to take the derivative of everything with respect to time. So the derivative of 3y is 3 dy dt. The derivative of x is dx dt. What am I looking for? Dx dt. Do I have everything else? Because dy dt is 4 over 9. And I don't need a calculator to tell me that that actually cleans up to be 4 over 3. Okay?
Yeah, it should be.
So Pythagorean theorem, geometry formulas, similar triangles, very common way of connecting unknowns in different stories. Okay?